So we are starting Unit 21 today. Like I said, we will learn this unit in 3 days really quickly. We begin with correlation. And correlation is a concept that a lot of students end up using in their IAs. And that's okay. It would be great though if a number of you use something other than correlation, because the IB graders don't like when you try to take the easy road. I'm just letting you know that they tend to grade a little bit harder when the students just go with simple linear correlation. They don't like it. Should you need to use linear correlation to write an IA, okay, just make sure it's stellar. All right. So let's go ahead and share the monitor. All right. Correlation refers to the relationship or association between two variables. It does not mean causing, it just means they're related. When you're talking about how things are related, there are several characteristics that you need to consider. How many things? 1, 2, 3, 4, 5. 5 characteristics. The first one is the direction that the data shows you it is flowing. Because we're specifically talking about linear correlation in this course. So other than which direction the dots generally point to, you're also going to be looking at linearity, meaning how closely does it fit a line? Linearity. The strength of a correlation. I mean, you can show that two things are correlated, but are they highly correlated? How strong is this correlation? Outliers is something you do have to worry about, but again, you have to be really careful about outliers. You can't just be throwing around the term outliers. Oh, that data point's far away from the others. I'll just call it an outlier. No, that's not how that works. And lastly, causation. Be very careful. Correlation does not mean causation. It's actually incredibly difficult in, let's just say, scientific studies to prove causation. Incredibly difficult. You could show two things are 100% correlated, but that doesn't guarantee that one is causing the other to be happening. That's actually remarkably hard to do in statistics. So this is what we mean by direction. Here are your 3 possibilities. The first one, the dots kind of go up and to the right. Yeah? Okay. Well, that is going to be a positive correlation because that line, if you were to draw it, would have a positive slope. And using that knowledge and that logic, the next one, if you were to draw a line through the data points, it generally goes down and to the right, as if it had a negative slope. So we'd say these things are negatively correlated, or negative correlation. Now the last picture, those dots are just kind of out there. And if you were to draw a line through them or let technology do it for you, it would end up drawing a line that was basically horizontal, which means you have no correlation. Correlation of 1L or 2? 1. Okay. So here we have 2 different data plots. The first one, a straight line actually models that data pretty well. So what we could say here is that this is a roughly linear trend. Now the one on the right. Could you ask your calculator to generate a line that those data points is model, like a line of best fit, so to speak? Yes, it will. But that doesn't mean it was the best model because those data points clearly curve a little bit more than they would be straight. So you would say that this has little or no linear trend. Yeah? Little or no linear trend. Meaning it's because it's curved. Linear means straight, like line. Meaning, could you draw a straight line through it? Yeah, a calculator would probably generate this, something similar to that. And even though it could generate a line for it, that doesn't mean it was the best model. 2 hands went up, yes? Kennedy? Don't worry, the questions are never that easy. The questions are never to say whether or not something has linear trend. Okay? So yeah, they have 1-point questions generally about this stuff, but it's never about linear trend. It's more about positive, strong correlation, more like that. Okay. Bria, was that the same kind of question?
Well, so the one on the left, it could be it can have a roughly linear trend and be a positive correlation.
Yeah.
Like they could do both.
Yeah, it could be several things.
Okay.
It could be several things. So not only could you say that it's linear, you could say it's a positive linear correlation, and you could also say that it's a strong or moderate linear positive correlation. It gives a lot of descriptors you can use. And I believe that's the bottom of that page. Yeah, flip them. Speaking of the strength, check these out. Now, this first picture is the exact same picture that you just had underneath linearity. Those dots are relatively close to that line, aren't they? They don't deviate too far away from that line there. So this would be called a strong linear trend, strong positive linear trend. So we say strong, ooh, it's red, well, whatever. Strong positive. Now the next one, the dots do kind of still go up and to the right, but when you draw that line of fit through there, they deviate further from the line of fit. These dots are more spread out. So we would say that this is a moderate positive correlation. And the last one, the dots are extremely spread out, but technology would still say they're kind of up and to the right. So we'd say that it is a weak positive correlation. Once again, are they going to give you dots and make you make a judgment on whether or not they're moderate or weak? No, they're not going to do that. Don't worry about that. It's not like how close those dots have to be in order for me to say that it's moderate or strong. Don't worry about that. That's not how it works. And all those descriptors, if they exist for positive correlations, so there could be a strong positive, a moderate positive, or a weak positive, it's also true for the negatives. You can have a strong negative correlation, a moderate negative correlation, or a weak negative correlation. Exact same ideas. So data points packed tightly together, strong negative correlation. Data points kind of close together, moderate negative correlation. And dots that kind of go down and to the right but are super spread out would be weak negative correlation. So this is very easy material at the beginning. I'm sorry, I think today's plan was just 1 lesson. I think that the plan for Monday is 2 lessons. I'll double check my calendar though. So outliers. If a data point is just outside of the mass of the data, yeah, you can say that it's an outlier, but only if it's so far outside the data that it's not even close to a linear trend at all. So this one we have the picture on the right, you see those dots are generally going down and to the right. Now, one of the 2 dots that's nowhere near the mass is completely off the line. So that dot at the top would be called an outlier because it doesn't even fit the trend of the rest of the data. Now the one to the bottom right, even though it's far away from the clump of data, it does still fit the trend, so it is not an outlier. If an outlier is the result of a recording error, of a recording or graphing error, it should be discarded. You cannot use it as actual data. Discarded or with a G? Yeah, with a C. Discarded. However, if an outlier is a genuine piece of data, you have to keep it. It doesn't matter if it flies in the face of what you're trying to show, you know? It's still true data. It should be kept. For example, I gave my Algebra 2 students a test today. And about 60-something kids took it. No, not 60-something, like 50 kids took a test. One student got an A. The average was an F. Now that kid, his data was not an error. So it still has to be used when calculating the average. Now, if it was an error of some sort, he cheated, or I somehow gave him credit for things I shouldn't have, then I wouldn't use his score to help me calculate my average. I would throw it away. But since it's legitimate, he's the one smart kid I have, he got an A. Good for him. I'm sorry? Yeah, he brings the average up. It's still an F, but I had one kid who sat the entire period staring at one question, and at the end was like, "Have a good weekend," and closed his test. So as soon as he left, I just submitted it. 0. I mean, you're not going to stare at one question the whole time and do nothing and think you're going to get more time. 0 home slice. Okay, causation.
Did you take it for a grade?
Yeah. And I can't wait for his mom to break a foot off in his butt.
That's so funny because you weighed them 80% and he's never.
No. It's Algebra 2. 60%. The A? Nicholas Reese? Algebra 2. Regular. Correlation between two variables does not necessarily mean that one variable causes the other. For example, let's say you decide to do a study and you are trying to relate the temperature outside and say the temperature outside and the number of teachers that called out of school that day. You might find that when it's hot, for some reason, it also happens to coincide with teachers calling off work. And it could happen religiously. Those would be highly correlated. But is the heat forcing these people to call off work? No. Now, let's say that you did the same kind of study on, I'm just saying it because it's happening right now, I'm getting a pool built. Manual laborers that are out in the sun. And you find out that on the hottest day of the year, wow, I got a lot of laborers that are calling out. And it's highly correlated. Could you show that maybe one is causing the other? Maybe. Because, you're out in the heat and it sucks, Hmm? Yeah, heat stroke is a thing. I've actually seen an IA done on average hours of studying and average grades on tests or GPA. I can't remember which one it was. Not correlated. I had a student do it for an IA, but what she tried to do was she was trying to show that the amount of, was it study time or was it sleep time? You know what, it was sleep time. And she was trying to show that IB students would have higher test grades or something like that based on the amount of sleep they got and things like that. And in the end, what she found out, which wasn't shocking to me at all, was that it didn't matter what level of student, because she had regular, honors, and then AP Bio. She had split them into 3 groups. She found that the 3 groups ended up with the exact same results. And I told her, I was like, well, of course they had the same results, because regular ed students, to them, the classes they're taking are hard. Honor students, to them, the classes they are taking are hard. So are your classes harder? Yes. But if you were to compare its difficulty to your ability and the honors difficulty to the honor student ability, you would see that the ratios are pretty much the same. So it was a great IA, and I loved that her results said, actually, it doesn't matter. I loved it. It was great. And then because it gave her really good reflection. She was like, her reflection was really good. And it's like, oh, well, that makes a lot of sense. I just assumed You know what? I remember now, it was stress. So it's not at all what you said. She was trying to go with average GPA and stress level, perceived stress level. And what she found was that it didn't matter GPA to stress to difficulty of coursework, that it was same across the board. It was really neat. She just gave him a scale of 1 to 10 and just said, your perceived, what is your, yeah, but your perceived stress level matters to you, doesn't it?
Yeah. 'cause that's gonna
The
be
amount of
your
stress that
grade.
you're under is probably the equivalent amount of stress that a regular ed student feels as well. Your coursework is harder, but you're smarter, you know? But the stress level ends up being normalized. It's actually,
Like kids that don't care as much.
yeah, but kids that don't care as much probably didn't take this survey. And I think what she was doing was she was targeting a certain GPA level. So I'm only looking at students that have a GPA of 3 or higher perceived stress level. And it ended up, so it was actually really neat. It was a neat IA. And her results showed absolutely nothing, which was fantastic. So, well, I graded it well, yeah. If a change in one variable does happen to cause a change in another variable, then we say that a causal relationship, whoop, I forgot the word causal, a causal relationship exists. A causal relationship
You know, Mr. McPherson?
exists.
Yesterday, I did.
If causation is not obvious, high correlation is not a justification for a causal relationship. Like I said, two things can be remarkably correlated, but that does not mean that one causes the other. For example, I notice on days that end with the letter Y, I wake up tired. Every single time. Is the day ending with a Y causing me to be tired? No, even though there's a 100% perfect matching correlation, one is not causing the other. Okay. So if causation is not obvious, high correlation, I'm just going to get lazy and go high correlation does not equal causation. How about that? That's nice. And that's the entire lesson. Your homework is about looking at data trends, and I'll scroll. Your homework is like to look at stacks of data, describe, is it strong, is it weak, is it positive, is it negative, is it linear? Literally, that's all you're doing for your homework, and it should be a joke. And the homework is from the red book, I believe. No, from the black book.